Good morning, and thank you for joining us for NSX and Horizon, a security architecture for delivering desktops and applications with VMware. My name is Wade Holmes. I'm a senior manager with the technical product management team within the NSX Security, Networking and Security Business Unit.
And I'm Graham Gordon. I'm a senior staff architect with our EC business unit, and I kind of focus on Reference architecture around about Horizon.
So first we have our standard disclaimer slide. Anything we talk about today that is mentioned that's a future-looking feature, there's no guarantee that's going to be delivered. It's our standard slide, but majority of what we talk about today is based on our shipping products with Horizon and NSX and how you can use it within your environment to help secure your end-user computing environment. So we're going to start out with today's landscape and today's threat landscape and within the data center and why end-user computing with NSX and VDI, why they're important and how they can be applied to your data center and helping to secure your end-user computing environment. Talking about how Horizon specifically can help, then why NSX and the combination with Horizon, how together they can protect your infrastructure. We'll talk specifically about some capability of NSX, such as the identity-based firewall and other capabilities that tie in with Horizon to allow for a more secure end-user computing posture. And then finally, we'll talk about how to actually get started with implementing this within your environment. So why is this important? Why is VDI with Horizon and in the combination of NSX important to you? Well, today, the threat landscape has never been more dangerous to the enterprise. Attacks and attackers have become more sophisticated. It's not just about script kiddies trying to take down a website. These are organized malicious threats, whether it's organized crime, whether it's insiders, whether it's active cyber terrorists or attackers, hackers, or actually organized nation sites that are targeting organizations trying to exfiltrate data and create havoc for profit. When we've seen this from the breaches, whether it's the Sony breach or the Target attack or recent malware attacks, whether it's WannaCry or Petya, there's been a number of attacks that are becoming more and more sophisticated. And these threats are basically through the weaponization of cyberspace. Basically, attackers are using tools, malicious tools, to be able to attack your enterprises for profit. So Graham's going to talk about how Horizon can actually help this from a VDI perspective.
Okay. So before we kind of jump in and layer NSX on top of Horizon, let's explore from a security angle with Horizon how we can help improve your stance there. There's lots of different ways. We talk about centralizing the data down, the applications down, and the infrastructure down. And we're kind of centralizing down the attack surface there so we can do a better job. Rather than have a distributed environment that we have to worry about from a security point of view, let's centralize it down. We'll touch on stuff like just-in-time desktops and how they can help you optimize the OS and also keep that patched, how do you keep that up to date. And that's also applicable in terms of applications as well, because it's not just the OS that's vulnerable, it's the application as well that's been seen in recent attacks. It's been the point of entry into an environment. There's several ways you can then protect a Horizon environment once you've got the OS and the applications and your data there, including going as far as putting NSX on it as well. So we'll get there. So let's start looking at data centralization. And it's often overlooked in terms of one of the key benefits of VDI. Why do you do it, and how do you sell it back to your organization as a benefit? Don't belie the benefit here. We're going to centralize disparate systems down. We're going to take data off laptops, endpoints that users are using right now that are left on trains, left on airports, and they're lost, and they're vulnerable. There's also thousands of protection points you need to worry about from a data security point there. So let's collapse all of it down, remove it from the end user, bring it back into the data center, and let's do a better job about protecting it centrally. Because we protect it centrally, we can then do stuff like back it up, restore it, do disaster recovery in a lot better manner. So there's lots of things we can do by centralizing that down that brings benefit there. We've seen a lot of organizations have benefits around about auditing, e-discovery, PCI compliance. Because they've centralized all their data down into 1 or 2 touch points, the effort involved goes from 5 million to 1 million. So really big savings in those environments. And lastly, you're going to be more proactive. If I've centralized stuff and I've got control over it, because it's not out on everyone's devices, I can now be more proactive about how I react. The ransomware demand coming out, I get news of it. How do I protect myself against it? Well, instead of having to touch thousands of points there, I now can focus my attention. And that attention is really enhanced with stuff like just-in-time desktops. So hopefully you've all heard about this, all heard about the message around about being able to create desktops very, very rapidly, 1 desktop per second per vSphere host. But what's the benefit of that to an OS and the security stance? We can now create desktops very, very rapidly, but we can also then patch them very rapidly. So we need to drive an OS patch in there because of vulnerability in SMB1. Let's patch our master, and let's go and create new desktops, create instant clones. Because they're 1 per second per host, I can do that very rapidly. I can do it in the middle of the day with really little impact on the end users. They log off an old desktop, they log on to a new one, and it's patched. So to compare that, you have to look at how you've done, and I'm sure you can probably tell me better than I can, how you do patching in a physical world. There are lots of tools out there, and everyone's got their own processors doing it. But in general, they're not 100% successful. You've always got the 1 or 2 outliers, the 1% of desktops that don't get the patch, or they don't reboot properly. So are they protected? They're not reporting back. Are they now a threat in my environment? Are they going to be the source of a spread? The other thing you've got to look at is a lot of patches and a lot of updates to the OS actually need a reboot of Windows to take effect. The files are there, the registry entries are there, but you know what? Until it reboots, that process restarts, you're not actually protected. So how can you be confident you've restarted all your PCs? Very difficult to tell in a disparate environment where you've got disconnected users only coming into the network occasionally, or maybe they never come into the network, maybe they work from home. How do you patch those environments? So, difficult.
And I would say the impact of not patching your environment is pretty obvious in the real world today. I mentioned a few events, the WannaCry virus, one of them. It was based on a threat called Eternal Blue that has been known, and a patch was available, and it affects older OSs. But because most organizations had not patched their environment, that worm was able to spread rampantly. So being able to make your operation more efficient through a solution that can actually allow for patching to become operationally feasible is critical to ensuring your security posture.
Yeah, and it's an interesting one. The WannaCry, everyone jumped to the conclusion that XP was the culprit. It wasn't patched, and Microsoft hadn't been releasing patches for that quite a while, for obvious reasons. But actually, the most infected machines were Windows 7, and they were the culprits for spreading it within organizations. So don't assume because I'm running a later OS, I'm automatically protected. There has to be good hygiene there. And VDI can help you achieve that hygiene. So if we compare that and we look at how we patch in the VDI world, how do we do that in the virtual world? We go back to our master, we apply our patches, and we just push that image out. We tell it to create new clones. There can be link clones with Composer or instant clones. Now, obviously, if you're doing link clones, the recompose is a bit more onerous. It's going to take a bit more time. There's a bit more impact on your infrastructure. So you need to consider stuff like the overhead on your storage. With instant clones, because we're cloning them very rapidly, they're running already with no power operation, we can do that with really little impact on the infrastructure there. I can do it in a rolling fashion, so I can pre-prepare it and then have it run in batches. So I'm going to do batches of desktops and not affect all my users. So again, that user logs off a potentially exposed desktop, they log back in, they're going to get onto a protected one. Other thing to think about in a VDI world is, what if you push out a patch and it breaks something, right? It breaks an application. My business is down now because that's my key application. If you push that out to physical worlds, how do you roll back? It's quite difficult. You end up running about to machines and fixing stuff. The VDI, just recompose the pool, push a new image out, right? And again, it'll be as rapid, 1 per second per host. So the other thing to get in job is, the OS is not the only attack surface here. Right? Patching Windows isn't going to get you fully protected. A lot of recent attacks have come through the applications, some as patches for those applications. So again, the rollback of those patches can be equally important. So when we think about how do I update my applications, how do I keep them refreshed on the latest version, the latest patches from that vendor, becomes equally as important as the OS. And do I patch that for my thousands of machines, or do it once centrally and then distribute that change? So with that volumes, we've taken that model. Instead of installing applications into the OS, we basically attach them. Again, there's several sessions this week covering instant clones and app volumes. I'm not going to go into too much level in this. Again, what we're doing here is we're taking a virtual disk that's got some applications installed in it, and we attach it to a Windows machine that happens to be a virtual machine. So virtual disk with applications attached. Key here is we're going to attach it generally when you log in as a user based on who you are in Active Directory. When you log off, we're going to unattach it. So what's going to happen, we want to push a patch into my application. As an administrator, I'll take that virtual disk, that app stack, I'll go and make my changes to it, I'll patch the application, then I'll just change the assignment. So I'll take away the old one, and I'll give you the new one. You log off, we're going to unattach the old one. You log back in, you're going to get the new updated application. So from a user's perspective, they log off, they get the patched OS, they get the patched application stacks. You've done it once in the master for the OS and once in the app stack for the applications. The other thing we can do with Horizon is lock down the environment. Constrict or restrict the functionality that you want users to be able to do with the environment. Do you want them to be able to copy, paste, print documents when they're outside the environment coming in through an external firewall? They're coming from a particular device or a particular IP address, or several other conditions here. What we can do here is lock down the functionality of Horizon. So we can change the clipboard, we can change the copy-paste, we can even tailor the bandwidth profile. So you're coming from inside the network, I'm going to open up the profile and give you a really good experience. You're coming from home over an external internet connection, I'm going to take that profile down and give you a lesser experience because I know your bandwidth isn't quite capable of it. So we can really tailor the security stance based on where you're coming from and those conditional policies. And to marry that, we need to provide secure external access. So we've had security server for many, many years with Horizon. That's still there, but really we're focusing now on Unified Access Gateway. This is secure edge services for not only Horizon, but a lot of other EUC products. So it can reverse proxy into stuff like Identity Manager, it can do a VMware tunnel into AirWatch, it can do per-app VNing, it can do identity bridging. So lots of things it can do there to give you secure edge services into your internal resources. The other good thing it can do is it can do DMZ authentication. So we can do stuff like certificate-based or SAML-based or inter-radius, where the Unified Access Gateway in the DMZ is going to go and do that authentication for you. So it's not going to send any traffic into your production network until you've authenticated. And then it'll allow you to connect through to stuff like a resource, a Horizon resource. The other thing we're going to add very shortly in Unified Access Gateway is device checking for Horizon. So we can then do a check on the device. Does it match particular attributes that we want that device to have? And if it does, we're going to allow it access through to Horizon. If it doesn't, let's block it and tell the user why. So that's coming soon. So hopefully that kind of gives you a picture of how Horizon itself can help you improve your security stance. We're going to move on and look at how NSX can take it further.
All right, thank you, Graham. So first, I'm curious, how many people here have actually implemented NSX in their environment? Okay, a good amount. Oh. And how many people are interested and want to learn more about how NSX can help their environment? Okay, so about 60-40. All right, cool. Well, first, let's talk about why is NSX important in a VDI environment. So Graham mentioned a number of benefits of VDI, but still traditional traffic within the data center is still north-south traffic. And as you collapse all of your resources, your VDI resources, into a consolidated environment, you're able to, while the capabilities of VDI are able to increase your security posture with all the capabilities of having just-in-time desktops, if your network isn't actually isn't protected for VDI, then you can actually have an additional attack surface and actually increase your attack surface because you now have more consolidated VMs in a more consolidated area and a single layer 2 potentially that can then have threats that can move laterally across the network. So while there are tons of benefits to desktop and application virtualization that we've gone through and mentioned and Graham went into in pretty detail, there's still the challenge of the actual network and making sure that your network and how you architect your network for your VDI infrastructure isn't lagging behind. So with the multiple endpoints and VDI endpoints now on a consolidated data center that allows for more expansive east-west traffic within that VDI environment, you now have to potentially worry about a new threat vector, a new attack vector. So if you look at how organizations and how threats actually proliferate, a number of these threats, such as I mentioned the worms, insider attacks, these start from the inside where somehow they breach your perimeter, they learn your environment, they laterally move across your environment, and they're looking at basically the weakest link to infiltrate and your network and exfiltrate data. So this may be, you may have a remote office, branch office that's in some area that isn't as secure as your main office. It may be a partner data center that has access to your environment, and they're the weakest link and they're able to breach that perimeter. Once they are able to breach the perimeter, then they're going to discover weaknesses and move laterally across your network. So traditionally, how you would secure this in a physical environment would be to put firewalls at all the different access points. But as you collapse down your VDI environment into a centralized data center or centralized data centers with virtual machines, that becomes much harder if your networking is based on centralized physical networking. And typically, to actually segment things down to the granular level that you would need to have a secure security posture, it becomes operationally infeasible and also extremely complex to manage. So basically, you end up looking at something like this in trying to manage this in a virtualized environment. This is not pretty, but this may be a headache some of you are familiar with. I see a couple of guys nodding over here. So this is where we enter NSX. So NSX is VMware's networking and security platform. And basically with NSX, we have a capability to allow for a per VM or really per VNIC firewall through our distributed firewall capability so that we're able to now segment traffic without having to hairpin traffic through physical infrastructure. So before NSX, basically, where you'd implement firewalls at your physical firewall, centralized firewall, and you'd have to have two VMs on the same host, traverse the physical network to be able to have some type of security context. With NSX you're now able to implement a firewall rule based on the NSX distributed firewall and no longer have to traverse that physical network to have an enforcement point. So this not only makes your security posture stronger within your virtualized infrastructure, it will make your physical infrastructure, network infrastructure more efficient as you're no longer having to hairpin traffic that doesn't need to travel through the physical network. So how does this tie in directly with Horizon? So I mentioned NSX and distributed firewall, and basically with NSX, we implement this concept called micro-segmentation. So micro-segmentation is basically being able to take a least privileged methodology to network security. The concept of least privilege has been around forever. Basically, it's saying that a virtual machine or application should only communicate to the machine that needs to talk to on the actual ports and protocols that it needs to communicate on. So while that's a simple concept, in the real world, it's actually very difficult to implement on an application-to-application basis, especially with physical infrastructure. So with this micro-segmentation concept that we're able to implement with NSX, we're now able to have desktop-to-desktop control on a very granular basis. We're also able to protect the infrastructure for Horizon itself. NSX also provides edge services through our centralized virtualized appliance to allow stateful services such as load balancing, centralized firewall, virtual firewall, NAT, VPN. And then we also provide network virtualization capabilities. From a VDI perspective, typically our customers start with the micro-segmentation and security use case. That's probably the simplest and lowest hanging fruit from a VDI and end user computing perspective. But you can also gain benefits from the edge services that are available through NSX, whether it's by load balancing, the Horizon Unified Gateway, and also network virtualization, and be able to quickly spin up additional layer 2 networks, or even having multi-site solutions that allow for VXLAN overlays across different sites.
I suppose the key thing there is, start simple, start with micro-segmentation, work your way over to network virtualization. Micro-segmentation can be done all within the vSphere realm, so you don't have to go outside, talk to your networking colleagues and stuff like that. We can do it purely on the VDI host if that's what you want to do, or the infrastructure host, and you don't have to involve a network conversation in it. Yeah. And then you can move to that over a period of time.
Yeah, that's a key point, and that's a piece that a lot of people are afraid of NSX because, we're never going to get the networking team to buy into this, or things are very siloed within the organization, and you think it would be a project that would last months or years to get the necessary approval. But to implement a security use case in micro-segmentation, that it doesn't require the network virtualization piece, or you can even do it without edge services and focusing just on the traffic for your VDI infrastructure. And from an implementation perspective, we now have tools within NSX that makes this relatively simple. So I was mentioning before, the use cases are basically how NSX can be used with Horizon. So there are 3 key use cases. One is to protect the actual Horizon infrastructure itself. So basically allowing for protection of the external communication of Horizon components and protecting the control between the actual Horizon components within the architecture. So obviously the Horizon management cluster and management components are the keys to the kingdom. So you want to keep that locked down as much as possible from any external threats that may be trying to move through your network and find higher profile targets and assets. Then there's protecting the actual desktops themselves. I would say in most cases in VDI, you don't need desktops to communicate with each other. They just need to communicate with the back-end resources, application resources that they need access to. So by default, you want to have all your desktops segmented and have a rule that no desktop can communicate to each other within the enterprise. With NSX, this becomes extremely simple, whereas with physical centralized firewalls, this would be a complex endeavor with hundreds or potentially thousands of rules that would be necessary to do so. We also allow for capabilities that tie in third-party services such as agentless AV, next-generation firewalling, and IPS IDS, and which we'll talk a little bit more as we go forward. And then finally, we have user-based access controls that are enabled through identity firewall. This allows for and makes it more powerful that just-in-time one desktop concept that Graham mentioned, where you're now able to not only provision a desktop that has all the application provision just in time by the app stack for the app stack, and have the OS just provisioned in time, but then also the firewall and security posture provisioned just in time based on the user and user session that is accessing that desktop. This is all based on integration with Active Directory. So let's talk a little bit about protecting actual Horizon infrastructure. I mentioned how important it is to protect the infrastructure and how you need to protect this because this is the key to kingdom. Obviously, Horizon, full Horizon implementation has a number of different pieces. There's a unified access gateway, there's the connection servers, there's app volumes, then there's the Horizon RDSH server, we've implemented RDSH. So all these pieces you want to be able to protect on a more granular basis when you can easily do so through NSX and distributed firewall. So if you look here, so there's obviously a huge amount of ports and protocols, and it's quite complex communication that happens within the actual full Horizon suite of products. So
everyone gets this, don't they? Everyone understands this. It's an eye chart, and that's the point. If you start mapping out the traffic flows, it gets quite complex. And if you have every type of protocol, network protocol, and display protocol, then it gets even more complex. So where do you start in terms of segmenting stuff? How do you understand the traffic flows? Right? This is complex. So we've mapped this out for you. This is a relatively recent asset we created called the Network Ports Diagram, updated for Horizon 7.2. The link's on the deck that you'll all be able to download later and understand the flows. This is the most complex version of it. I put it up here for a purpose. Yeah. Right.
And there's going to be a test on this at the end of the session. So you may look at this and say, okay, you have all these flows, and we're just talking about the management cluster. How do I protect this and implement this least privilege model with NSX so that only the specific flows with specific traffic flow with specific ports and protocols are actually allowed to communicate with each other in this complex manner? So one thing we've done to make this easier is we actually created a Horizon Service Installer for NSX that automatically creates the necessary security groups and service profiles that already have the port definitions defined so that you don't have to actually figure this out or actually have to create all of these for your Horizon infrastructure. And so this makes protecting the management cluster and management infrastructure for Horizon much easier. And actually, another thing I do want to mention as a methodology to being able to discover different ports and protocols for applications such as Horizon, the Horizon infrastructure, NSX actually has a tool called Application Rule Manager. And that tool actually is a network flow analysis tool that will automatically learn the behavior based on all the communications of an application or application set, and it will actually then allow you to automatically create rules based on those flows. So even if without this installer, you'd be able to then select all your management components, discover all the different ports and protocols that are used by Horizon over a time period where you've made sure you access all the necessary functions, and then create those firewall rules based on that automatically through this application rule manager function. And that's actually a key feature that we added within NSX 6.3, which came out earlier this year. We're now at 6.3.3 as our NSX vSphere release. That enables and makes it much easier to create least privileged micro-segmentation rules within an environment. So here we're looking at a sample configuration of micro-segmentation of rule table, where we have the infrastructure rules for the management clusters on top, and then we have the desktop application rules at the bottom, where we're now able to create rules for your desktop to be able to segment the traffic so that your desktops aren't able to communicate with each other to stop lateral threats. So with NSX, I mentioned this would be very difficult with centralized firewalls. With NSX, you're now able to create a single rule that basically a default deny, and with that, whether you have 1 or 5 desktops on a single L2 segment, or 2,000-3,000 desktops on a single L2 segment, that single rule is going to be able to enforce your ability to segment traffic from desktop to desktop by default. So next I want to talk about the identity-based firewall. So basically, identity-based firewall allows for policy-driven micro-segmentation based on user and user sections. So I mentioned it's specific to AD security groups based on your AD security group posture, and distributed firewall rules are defined based on Active Directory membership. So users can use either physical or virtual systems that have been joined to AD, but the destination system must be a virtual machine. So what this does and what this allows is basically, I mentioned, allows this just-in-time desktop concept, or one desktop and one pool concept within Horizon, where you're able to use a single pool, and then based on the security profile, you're able to now map users to that pool and have the resources along with security profile provision just in time as that user logs in. So a little bit why is this so powerful? Basically, before NSX, you'd have all desktops on a VN could potentially, on a VLAN or L2 segment can communicate freely, and you'd have this risk of this wider attack surface and have lateral threat movement throughout that L2 segment. But with NSX, you now are able to allow for this granular micro-segmentation, and then you're also able to allow on a per user basis, have firewall rules that are defined by the user, and also allow for a more efficient posture in Horizon, and be able to scale down the number of pools necessary, so you don't need a separate pool for your one set of users. For your finance users versus separate pool for your HR users potentially, you could have a single pool, and based on identity, that profile with the security posture gets provisioned automatically. So, and I've been talking about this and alluding to this. So basically, this secure just-in-time desktop concept, I mentioned, you can now have this single pool and a stateless desktop pool, where you now have the policy that's driven from NSX on demand, you have the application layers driven on demand from app volumes, and you have personalization through Horizon and UEM that's driven on demand. So basically, now you just have this single pool, and all of your services are driven on demand. And this allows for a truly secure footprint in that you never have data at rest that you have to worry about that's can potentially be corrupted from a resource, OS or application perspective. And if your OS or application does get compromised somehow, once you do a refresh from this pool, it'll blow it away, and you have a new pristine environment.
I think that's key here. You know, what we're doing here is with very, very few components, we're then able to spin up a customized environment for the user based on policy. So we define the units of the components that make up the end desktop once. We define the policy and how it applies to the user. And then when they log on, they're going to get all the different components. They're going to get the network stance, they're going to get their OS stance, they're going to get their application stance, and also their profile data through Unified Environment Manager as well, all based on who they are at logon time. So we stitch it all together, give them that persistent experience back. But all the bits that made up, they're actually non-persistent. So we won't really care about them. We can update them, we can patch them, we can throw them away.
So you may be wondering, okay, this is great, and we're talking about the importance of end users that are accessing our VDI desktops, our environment, but what about mobile devices? I mean, all of us have mobile devices, then all of us have a proliferation of mobile devices and apps that need to access your enterprise environment. So here's where we tie in our capabilities of AirWatch, and we have to have integration with AirWatch and NSX to allow for a per app VPN capability that allows for end-to-end micro-segmentation of applications within your mobile device, so that only the specific application on the mobile device can access only the micro-segmented back-end resources within the data center. And basically, this is, instead of having a device-level VPN, where you traditionally, here you'd have your mobile device that can now access all of your resources, which has this basically double fan-out issue, where if a mobile device gets compromised, it can proliferate to other apps in a mobile device, and if your back-end gets compromised, it can proliferate. basically with the app level VPN, now only the application, specific application has that connection, and then it has a connection specifically to the micro-segmentation resources within the data center.
So I think, you know, the way I think of it here is traditional VPNs open up that whole device into the whole data center, which was fine in the era of a corporate-owned device. I'm going to give you a laptop, and it's corporate-owned, and it's controlled, and it's imaged, and only the employee uses it. So we'll put a device-level VPN on. And now I have several devices, including tablets, that my son picks up, and he downloads dodgy games, and don't know what else he's doing on it. And do I want to open up that whole device to the whole network? No. So I want to open up only the application and trust that application. And I don't want to trust the whole data center, I only want to trust several servers. So that matching up of that per app VPN to an NSX profile and firewall, you know, kind of segments both together. So you got to think of, this isn't just your traditional devices anymore, this is any device. But you don't want to manage all those devices, you want to just apply a policy that controls them.
So I mentioned that the primary use case that most people start with NSX and Horizon integration is security and implementing micro-segmentation, but there are additional use cases that customers utilize NSX for Horizon that can help achieve additional efficiencies within the data center. And one of them is with load balancing and load balancing the Horizon infrastructure. So I mentioned NSX is a network and security virtualization platform with a number of capabilities, and one of those capabilities is actually providing north-south stateful network services that include stateful firewall for north-south traffic, a load balancer, VPN capabilities, both L2, L3, and SSL VPN. Routing and NAT capabilities, include dynamic routing capabilities, and DHCP and DNS relay capabilities. And all of these are enabled through NSX's Edge Services Gateway. So specifically with the load balancing capability, this is one of the main features that is utilized in conjunction with Horizon deployments. And our load balancers basically allows for a number of capabilities, including multiple virtual IPs, multiple load balancing algorithms, different session persistence, configurable health checks, supporting application rules, SSL termination with certificate management, and your transport of full proxy modes. So this allows for you to now have a per tenant load balancer. So as you scale out your Horizon infrastructure for potentially different tenants or different sites or different groups within your data center, you can utilize Edge Services Gateway as you scale out without having to implement a physical load balance appliance as you scale the environment out for different groups or different tenants.
To look at how this applies to Horizon, you know, you're going to start by having an external load balancer kind of in front of your unified access gateways. And one of the other benefits of unified access gateways, there's no direct one-to-one relationship with our connection servers internally. So we can have as many or as few as we need there, and we just spin up extra ones very quickly in a matter of minutes. And with the load balancer in front of it, we don't really care if there's 2, 3, 10 behind it. With load balancers providing that virtual IP address. And from there, we're going to pass that traffic on to an internal load balancer that's going to sit in front of our connection servers. So we can see how we can scale up or scale down this environment very, very easily. You know, with the load balancer sitting in front of those two areas of infrastructure, we can have more or less unified access gateways. And if I need more connection servers because I'm increasing the scale of my environment, I just add more connection servers. Load balancing of those components are very, very simple, straightforward. There's no special requirements for it. We've documented all those settings, and we've also documented how we use NSX as a load balancer for it.
So another important capability of NSX as a network and security platform is our partner integration. So, and one of the main use cases for this, for end user computing and VDI environment, is for ageless antivirus. So basically, with NSX, we have a capability called guest introspection that allows for optimized antivirus, so you no longer have to have an agent on each virtual desktop. So what this allows is for you now to have a much more efficient manner of providing antivirus for your desktop infrastructure. So with this, basically, you're able to increase your consolidation ratio in your VDI environment, and we'll be able to see numbers such as up to 20% faster full scans, up to 5% faster real-time scans, and up to 30% more density or more VDI desktops within an environment where you no longer have a thick agent running on each of your desktops within VDI. This makes your infrastructure much more efficient and also makes it much more efficient operationally in managing antivirus on your desktop infrastructure. So how does that actually work? So basically, NSX has a capability called service insertion, and there's two actual APIs that are exposed that our partners utilize. We have both the NetX or Network Extensibility API. We have a guest introspection API. So antivirus, Ageless Antivirus uses our guest introspection API that allows for third parties to now use the DV filter that we have on a per VNIC basis that also allows for our distributed firewall capability and be able to traffic steer traffic to these solutions. So whether it's for a next generation firewall for IDS or IPS through a network extensibility capability or guest introspection that allows for the agentless AV, this allows for chaining of services and then tying that back into the security policy model that is now exposed by NSX. So I mentioned the security policy model is exposed by NSX, and that you interface with that through NSX Service Composer. So what does that mean from a mitigating threats and tying this all together? So here's an example of using NSX Service Composer and a potential of third-party service insertion for antivirus. So basically, a third-party antivirus solution that implements agentless AV will utilize NSX security tags so that if a malicious threat is found on the VM, it'll automatically tag that VM and it'll automatically quarantine that VM via NSX. And then you now can quarantine it, remediate it, perform any threat analysis that's necessary. And then once that VM is cleaned up, you can then remove it and put that and have that VM reprovisioned and put it back into service. This can happen all automatically through NSX and through the policies implemented through Service Composer tied in with your third-party AV solution. So you may be asking then, okay, this all sounds great, but how do I get started? How do I actually move forward to actually implementing some of these things? So let's talk a little about some of the tools and some of the recommendations actually getting started in implementing Horizon and NSX together. So I mentioned some of the benefits. So I think just to go overview, obviously we have now the capability to not only secure your infrastructure, have provisioning policy be automated and just in time for desktops, and then also being able to allow for advanced networking and fast and simple networking provisioning through network virtualization. So tying this all together greatly enhances both your security posture, your operational posture, and in turn makes your data center more sufficient and more secure. So what do I need to actually get to this point? So I mentioned it's very simple to actually install NSX and actually implement the security use case. So NSX is installed through an NSX Manager appliance, and you go through a process of actually pushing down the virtual installation bundles, or basically preparing the hosts on each NSX server. And once you do that, you now actually have the ability for the distributed firewall and be able to provide that per VNIC firewall for all your VMs that are provisioned. It also automatically gives you the ability to have visibility into all of the VMs. And the visibility piece is also important because you're not going to implement the firewall, automatically start blocking everything. You're going to need to learn your environment, and through either tools like Application Rule Manager or potentially other capabilities within NSX, you're going to now have the environment. You're going to have that visibility and are able to look at your environment and learn what rules you need based on the traffic flows that you're able to now observe on a per VM or per application basis. So your next step would then be able to, once you have that information as far as what you need to block and you have that visibility, creating your groups and services, creating security groups, and then building out your distributed firewall rules, and obviously testing. But looking at that process, Graham was.
So I think, there's lots of hands there saying people have installed NSX, which is great. For those of you who haven't, this is not a hard thing, it's not a complex thing, there's very little risk here. Something you can do in a test environment very, very quickly within about 10-15 minutes. You can spin up the NSX appliance, prepare your hosts, you don't need to reboot them anymore, right? And then we can start creating our services, service groups, and our security groups. And again, the Fling can help you prepare all those as well. So I can get to the point of all the rules are there, I just need to populate my security groups. What are my connection servers? What are my unified access gateways, my app volumes managers, etc.? Populate the security groups. The one step I'd recommend you also do is go and exclude a couple of VMs, like your virtual center. Because if you put a deny all rule in there and apply it to every VM in your environment, guess what? Your virtual center can't talk to anything else, so you can't get in to change the policy. So go and exclude that. I've caught myself out there once.
Yeah, if you do happen to make a mistake, you can then turn it off, but you have to do it through an API call. But it is a good tip as you're going through the deployment, initial deployment, not to lock yourself out by making things too secure and locking down your own management capabilities. So, so as you look at now, I talk about this model of least privilege through micro-segmentation, and I think we talked a little about preparing the host and implement NSX, and in a POC environment, we can do this extremely quickly. Obviously, to get to the point of having a true least privilege model for all of your infrastructure and all your applications, that can be more of a timely process because you need to learn and know your applications to make sure that only the flows of your applications are occurring. But to do that, I mentioned we have a number of tools with NSX now to make that much easier, and also additional, whether they're tools within NSX or additional tools that I'll talk about here. So we mentioned the first step, very easy, deploying the OVF, associated with vCenter, potentially deploying any third-party security vendor appliances if you're using antivirus, ageless antivirus or IDS IPS or anything that ties into our service insertion framework. And then next you want to learn your environment. This is the key, and this is the part where people potentially will have the most trouble depending on the process used, but you need to look at a pragmatic approach where you can utilize tools such as Application Rule Manager, and taking a per application or per environment or per group basis and learn those flows. You can also take IP fixed data and to learn the environment. Or if you're utilizing Log Insight, you can actually tie in Log Insight and utilize the log data to automatically create rules. And we have some scripts out there and guidance on how to do that. But really the easiest way is the built-in Application Rule Manager that allows for this to be done in a very simple graphical manner. If you're utilizing vRealize Network Insight, that's another tool that can do analysis of your environment and network flows on a per data center large scale basis to analyze traffic flows and then automatically create the necessary rules within NSX. And I mentioned you can also look at log data such as in Log Insight. So once you've created those applications, once you've discovered those flows, you understand your applications, or maybe you already have all your applications documented. I mean, most environments don't, but if you do, then you're already ahead of the game, and I would suggest that's necessary for every environment to have a good security posture. Then you determine your policy model. So basically you identified the flows, you then now can create the necessary security group, security policies based on that. And then you apply this based on either firewall rules, table, or if you're using more dynamic objects that NSX allows through Service Composer. one of the things I haven't really talked about was the ability for NSX to use dynamic objects so that security rules aren't only tied to just traditional IP and 5-tuple rules. You can tie rules to things such as VM name, OS, so that if any Windows 2003 or 2008 OS automatically comes in network, it's automatically applied to this security group with the specific security policy. And also a security tag. So all objects within vCenter, you can define and create security groups and security policy based on those objects with NSX. So where do you want to go to learn more? There's a number of resources out there, whether it's going out to the NSX virtualization site, the VMware homepage. There's a number of hands-on labs and a number of demos in the NSX booth that shows NSX both protecting Horizon infrastructure and protecting Horizon desktops. We have a number of other sessions that will talk a little bit about different aspects. And we can also, I said, always recommend going out to the hands-on labs, getting the hands-on experience of looking at the product and how it actually can be applied in your environment.
So just a little bit of promotion for a session that's coming up later this afternoon at 3:30 with Sumit, who's the General Business Manager of our EUC business unit, and Sean, who is the CTO for our EUC within VMware. And they'll be covering, delivering new user experiences with the digital workspace. So very good session coming up later this afternoon if you have it in your diaries.
So definitely we have a few minutes. Definitely if you have any questions, please come up to the mics and we'll take some questions.
Yeah, I do have one. We're still hanging on to FeedShield, obviously, until we get to NSX implementation. Can maybe you give kind of an overview of how you would transition? Is it something that has to go cold turkey? Obviously, it's easy in a new implementation. You can just install the appliance and away you go. But in an existing environment, what are maybe some cursory or high view level steps you would take to migrate? Because we currently do use Trend with FeedShield, but obviously we want to move forward.
Yeah, so I think one of the main things in moving and upgrading from an existing vShield VCF environment is looking at the compatibility matrix and making sure you may not be able to go through a one-step jump, especially to the latest version of NSX. You're probably going to have to iterate from vShield to an older version of NSX and maybe a two-step upgrade process. So that's definitely something absolutely to take a look at the upgrade compatibility list and also take a look at all the notes for install notes, release notes for all the versions for any caveats, because there are going to be a number of considerations.
Hurry up. So I have two questions. One is the AirWatch thing you said. So I was wondering about how you guys support different products. Because I know you guys want us to all use AirWatch, but the reality is we don't. So we use Mobile Iron, for example. How would NSX integrate with something like Mobile Iron? So that's my first question. My second question is, how does, say, your DDI, that's the buzzword for DNS, DHCP, and IPAM. So how does that compare to InfoBlocks? I know that you have an InfoBlocks here, and they have NIOS. So why should we use your product versus InfoBlocks? And another comment just to this guy right here, we are using NSX with Trend Micro. It's awesome, awesome, awesome. We did have one trip up, which is with the VIBs. So Trend Micro doesn't really care about full integration with NSX, just their own thing. So they only cared about guest introspection. So you don't have to worry about the VIBs for the full NSX unless you're going to full NSX. But we didn't for our VDI. So we got caught up with that because the instructions to install Trend Micro had that, and we got completely gotcha. So
okay, so let me make sure I heard your questions properly there. So the first one was
AirWatch or Mobile Iron.
If I'm not using AirWatch, I'm using Mobile Iron. How does that integrate into using NSX profiles? The reality, it doesn't. It's a third-party product. Why would I want to use AirWatch? Well, there's several different reasons I can go into afterwards. One of them is it integrates in because we're all from the same company. So it integrates in so that it calls and understands there's NSX policies there. And when I connect through a per-app VPN, it knows how to integrate into NSX policies. Mobile Iron has nothing, so you're not going to be able to do any of that. The second one I didn't quite catch. Maybe you can...
I think it was IPAM.
Sorry. Do you want to...
Was it IPAM integration?
Yes. So I saw you mention IP Big Fix. No, IP Fix.
Yes.
So is that?
So yeah, so IPFix is different. NSX does not is not an IPAM solution. We can integrate with solutions and info blocks, and if you're tied into your orchestration engine, but NSX does not provide actual IPAM. The IPFix was actually for flow data to be able to import the flow data to be able to create security rules, but it wasn't about IP address management. And then the third question, okay.
That was a comment, so we'll go over here.
You mentioned on your gateway product that you'll have endpoint analysis. So will there be an agent that'll have to be deployed on each endpoint? And if so, what platforms will be available?
Okay, so the question is,
through Windows?
In endpoint, when we're talking really antivirus offload, do we have to install anything in endpoint?
You were talking about your universal access gateway or whatever you guys have
Unified
labeled
access gateway.
that will be able to do endpoint analysis before letting that device connect in, right? So there's either going to be an agent or something in order to enable that scan of that user's end device.
No, there is no agent on that as part of the Horizon client going to come out.
Okay.
And we're going to use a third-party service to do that kind of security stance. What are my criteria for saying this is a safe device I want to allow in, or no, I want to stop it? So we're using a third-party service call out to do that.
And your client will be having that feature in Linux, Windows, and iOS?
For all the Horizon clients, correct. Okay.
Okay, go ahead.
Hi. Just a quick question was, I saw there was a slide about VMs being quarantined when there's an incident, I guess, on an endpoint. How does that get handled? Like, let's say, how does it affect the end user as far as do they get provisioned a new clean system? Or?
It's fading in out. So I think I get the gist of the question is, in terms of if we quarantine an end device or a device that user is using, like a desktop, how does it affect the user? You can decide. So, how does it affect the user? Do we want to just kill the desktop? If it's an instant clone, yeah, that's probably the right thing to do. We detect something that suggests that there's something malicious inside that desktop, and it's an instant clone with that volumes and stuff like that. Let's just kill it, right? They're all transitory bits and pieces. Let's just not bother fixing it, throw them away. So let's just disconnect the user, let them reconnect and log on. Now we need to work out how we message that's what's happened to them. If you care about the desktop and you want to fix it, then we're going to quarantine it. You can decide through the firewall rules how much access you give the user, if any, until it's fixed. Most people will say, no, the user's chucked off it. They can't connect. We've disconnected their display protocol until we fix it and we bring it back out of quarantine, and then we're going to allow them reconnect.
They would have to reconnect, correct. Yes. If a non-persistent desktop, that's the beauty of non-persistent desktop, or if it's a persistent desktop, then it would be a more intrusive situation.
Reinhardt, you're not allowed to ask me. No.
Are we ever going to offer global traffic management feature in NSX?
Say it again.
The
global.
GTM, so as far as I understand, we only offer local traffic management with NSX. What about global traffic management, load balancing?
Okay, global load balancing. So yeah, that's something that has been asked about many times. It's not on a short-term roadmap, but it's something that we have on a longer-term roadmap.
Thank you. Is there a limitation in terms of if I've got a pod block infrastructure and I've got multiple virtual center instances? Is there a limitation if I'm using NSX with my implementation of NSX and integration with NSX and the virtual center instances I have?
So we still adhere to the scale recommendations of VDI and the pod block architecture. So I guess there are a number of design decisions. Obviously, one is the scale and still having 3,000 desktops per pod.
2,000 per.
2,000, yeah. And then there's looking at whether you're utilizing universal logical switches, or is this a multi-data center environment, or if this is a single data center environment. And if you're utilizing universal logical switches, you're still going to be limited in the type of objects that you're utilizing for firewall rules. It'll be either IP set or MAC set, but you can still have a top level rules that are utilizing IP set and MAC set across data centers, and then for each local data center, you can have dynamic objects for local to that pod. So there are a number of design decisions to make and criteria. I don't say it's limitations. It's more just design decisions.
So I'm not limited to a single virtual center instance with NSX. I can use a single NSX manager.
Oh, it's not a single, no. It would be multiple NSX managers NSX manager and vCenter is still a one-to-one relationship.
Okay.
Yes. But you can have we have a construct called, basically have universal logical objects, which spans across multiple vCenters and NSX managers, but then that's where you'll have potential limitation or in the type of objects that you utilize for your security groups, whether it be IP set or MAC set. But then you can also still, for all the desktops local to that vCenter, still use all the other richer objects, dynamic objects local to that vCenter. Across the vCenters, you'd be able to use rules based on IP set and MAC set. And typically, we would see a combination in a design where you have infrastructure rules that may span across multiple vCenters and sites at top level rules, and then define more granular rules at a local site on a per vCenter basis.
Thank you, Wayne.
Okay, well, thank you very much for hanging about. Thank you.
Thank you.